guys. It's just math, y'all. There we go. Just math, y'all. All right, we're doing Cal 1. We are doing chain rule. We're going to do some more examples. Done a few already. Hopefully, it's not as confusing as it started out to be. Hopefully, it's getting a little better. And we did those two. So here we go. We're going to start with this next slide. We've got two more examples. Okay. So let's jump right in. We're doing the chain rule. We want to find y prime. And let's do this screen, see how the screen looks. Okay. And so y prime is going to be f prime of u times du. Okay. All right. That's how we do y prime. It's going to be f prime of u times du. Now, remember, u is the inside function, and that green is not going to cut it. All right. So this is the u. Okay, also known as your g. That's your inside function. All right, so here we go. So I'm going to do negative 15 to the negative, we got to subtract 1/4 power, okay, times the derivative of the inside. Well, the inside has a derivative of 21x to the second. Okay, and so here we go. Tried to simplify this out a little bit. Well, I've got to do 21 times 15. I used to have that on my notes, but I turned the page. I think it's 315. Yeah, 315 x to the second, and it's negative. About to lose that negative. Now the negative exponent means it's actually a denominator. So 7x, where did that come from? 7x to the third plus 1 to the 4th power. That would be that one. Okay. Again, we did the derivative of the function times the derivative of the inside function. Okay. That's what y prime is. Okay. All right. So again, the next one, the next one is a combo problem. This one is a combo. And I mean combo because we're going to do the product rule and the chain rule. This one's going to use the product rule and the chain rule. I'm looking for my example. I don't see it here on the page. Don't see it there. Let's keep looking. Anyway, here we go. So product rule. It's going to be the first times the derivative of the second plus the second times the derivative of the first. Okay, so now the first one is just x, and the derivative of x is just 1. All right, the second is x to the second plus 1 cubed. All right, so now here we go. Let's get it worked out. All right, ready? All right, chain. So we're going to do the first times the derivative of the second. The derivative of the second is going to be 3 times x squared plus 1 to the second power times the derivative of the inside, 2x, plus the second times the derivative of the first. We're going to simplify this out. When I simplify this out, I'm going to get a 6x to the second times x to the second plus 1 squared plus x to the second plus 1 cubed. Now, I can write this in factored form. I do see a common factor here. Remember, they always want things written with a common factor. And so the common factor on this one is the x plus 1 squared. Remember, when we're doing the factoring, we take the lowest power of what's common. And so we're going to do that one. So then x squared plus 1 to the second power is the GCF. And the leftovers are going to be 6x to the second plus, now if I take out 2 from here, that's going to leave just a 1, plus x squared plus 1, which can be simplified to 7x squared plus 1. And that is the official answer. Right there, a little simplifying mess on that one. Right, don't let the simplifying mess get you down too much. All right, let's go to the next one. Okay, so now this one we're going to do the chain rule and the quotient rule. This is also a combo. We're going to do a chain rule in combination with the quotient rule. Okay, so this is where sometimes it's helpful to introduce the u and the du. Okay, so remember the u is the inside function. That's the inside function. And the derivative of u, this is where the quotient rule is going to come in. Okay, this is where we're going to use the quotient rule. The quotient rule is low times the derivative of the high, which is 1, minus the high times the derivative of the low, which is 1, all over low. And so just the u and the du. So this is going to give me x plus 1 minus x, or just 1, over x plus 1 squared. Okay, so that's just the derivative of the inside function. All right, and so now when I want to do the derivative of y prime, I'm going to do 5 times the parenthesis to the 4 times the derivative of the inside function, because this is u. So this will be 5x over x plus 1 to the 4th times 1 over x plus 1 squared. Now, let's simplify this just a little bit and see what we get. We can simplify this up just a little bit. So this is going to be 5x to the 4th over x plus 1 to the 4th, x plus 1 to the 2nd, which if you remember, I can add those together. That is my official answer for y prime here. Now, I didn't always do the u du. Did you see that? I didn't always do the u du. So you don't have to do the u du, but I want you to see it. And sometimes when your inside function looks kind of complicated and you're a little scared about it, you can take it to the side and just do the derivative of the inside function, okay? And then come back to it. So it's all up to you. I do want you to be aware of this u du notation, because as we start learning how to go backwards, I mentioned that, then that's going to be very helpful going backwards. Okay? All right. So this next one, again, the inside function, or the u, is x to the 4th plus cosine of 2x. All right. This is a combo. This is chain rule within a chain rule. Yeah, chain rule within a chain rule. So let's do this one. Let's do this one without the u. How about that? Let's try it just straight ahead and see. All right, now the key thing to remember is all you're going to do is add, every time you do the derivative, right, you're going to add the phrase times the derivative of the inside function. If you'll just add that to your brain process, then you've got the chain rule. Every time you do the derivative, just tag on to the end, times the derivative of the inside, times the derivative of the inside. You got it. Okay, so here we go. So this is the same as that. That's not y prime, that's y. All right, so that's y, so I rewrote it. So now I'm going to do y prime. I'm going to take the 1/2, it goes down front. All right, and then I'm going to subtract 1 from the 1/2 to make a negative 1/2. Okay, times, here we go, the derivative of the inside function. Okay, so now the derivative of the inside function is going to be 4x to the third plus, okay, so what's the derivative of cosine? Well, the derivative of cosine is negative sine times the derivative of the inside function, because you didn't do the sine of x. You didn't do the cosine of x. You did the cosine of 2x. So that's an inside function. And so times 2. Okay? All right. So now we got to simplify this. Oh, yeah. Do I have this one simplified out somewhere else? I sure hope so. I sure hope so. Well, it's not on that page. Not on that page. Not on that page. There it is. Okay. All right. So now this is going to give me, all right, so let's look at, this is 4x to the third minus 2 sine 2x. Okay. Now let's look at numerators and denominators on that. That's obviously in the numerator. Okay. That's obviously in the numerator. All right, but now this negative exponent indicates that's in the denominator. And the 1/2 means it has a radical on it. Okay, and then the 1/2. All right, so the 1 obviously is in the numerator and the 2 is in the denominator. Okay. Now, can I reduce? Absolutely. Sorry about that. Press the whole thing. Each technical term can be divided by 2. So that's going to be a 1, that's going to be a 1, and that's going to be a 2. This 2 on the sign, that's trapped inside that sine function, so we're not reducing that one. And there's my final answer. That's pretty gross. Yep, but you did it. All right. Do I have one more? This is it. This is a polynomial. It's a biggie. I gave you a whole slide for this one. Again, we're going to do multiple chain rules here. And remember, we're just going to tag on that derivative of the inside function. Derivative of the inside function. Okay, so here we go. Here we go. All right, so we're going to do y prime. Okay, so the 4 comes down front. Got this big honking inside to the third. Okay, so that's the derivative of the outside function. Now the inside, we'll just go ahead and copy it down. All right, times the derivative of the inside. All right, so now I've got to do the derivative of that. That's a product. That's the inside function. So I got to do the derivative of that using the product rule. Okay, so derivative of the inside. Right, derivative of the inside would be the first times the derivative of the second. Okay, now check out the second one. The derivative of the second is x squared. Hold on. The first times the derivative of the second. The derivative of the second is 2x. Okay. Plus the second times the derivative of the first. The derivative of the first is 1. Alright? So, we did the 4 out front times the that. Now we did the derivative of the inside. This is the derivative of the inside, or du. That's du right there. All right, so now we just got to simplify it. Okay, we can do this. All right, so let's times. This is going to give me, let's do a big bracket right here. That's what I was missing. All right, so let's do this. So that's going to give me 2x squared plus 4x plus x squared plus 1. Alright, and that's going to give me a 3x squared plus 4x plus 1. Right, I'm going to distribute that 3 in there. Which would give me x plus 2 to the third, x squared plus 1 to the third, and your final answer in factored form. Oh, factored form. Yeah, I got to factor this guy. It's 3x plus 1 and x plus 1. And that, my friend, is the final answer. I'm going to write it big so you can see it. 4x plus 2 to the third, x squared plus 1 to the third, 3x plus 1, x plus 1, factored here. There we go. Alright, chain rule. Derivative of the inside function. Okay. Alright, good luck with it. Hope that helps. It's just math, y'all. You can do it.